Machephy Eduworld.
Good afternoon, everyone. So, Newton's law of motion and friction topic we have completed. Now it's up to you to complete the questions of that from SC Verma. And after that, I'll be giving you this booklet. So you can complete from that. But first priority SC Verma hi hona chahiye. After that, if you can solve all problems of SC Verma on your own, then your basic concept is clear. So moving on to the next chapter. This chapter is also a part of Newton's law only, but taught separately for JEE examinations. And this chapter is known as circular motion. So circular motion can be categorized into two parts. Pehla hai kinematics of circular motion, and then later we'll be talking about the dynamics of circular motion. So first we'll start with kinematics of circular motion. Kinematics में हम forces की बातें नहीं करते, and in dynamics we'll talk about the forces which are acting on the body which is undergoing a circular motion. So kinematics and dynamics of circular motion. These two things we'll study. So in kinetics or kinematics of circular motion, we can just observe the body on how it is moving on a circle, and we'll derive some term for it. For example, before studying circular motion, I just revise a concept that we have discussed earlier. So if an object is moving on a circular arc, this is your arc AB. So this is your arc AB, and this is your center O, and this radius is R. So this angle theta is given in radians. Angle theta in radius, that is equal to length of arc AB. So arc length ke liye we use this curve sign divided by the radius. So theta in radians is equal to length of R, let us call it S, that is equal to S upon R. So this meter by meter or centimeter by centimeter, that cancels out and gives you the angle in radians, that is S upon R. This we already studied when I was talking about the fundamental quantities. So two fundamental quantities or add here besides the 7 fundamental, that is angle in radians and angle in steradians. So here we just need angle in radians. So circular motion study करने के लिए, of course, we need a circle. So you'll find a lot of similarity between this and motion in 2 dimension or motion in 1 dimension. So in this case, let us say your particle is initially at point A. Your particle is initially at point A. Or you may call this particle, इसका motion start हुआ A से, and at some time t1, the particle was at this point A. This is the origin. We need the radius of the circle. So radius of the circle is given. So particle का motion कहीं से start हुआ, t1 time पे particle was at point A at t is equal to t1, and t2 time पे particle was at p. And let us say हम जो original line है OO dash से angle measure करते हैं in the anti-clockwise direction. So this is your theta A, this angle with the positive x-axis, and theta B, that is angle rotated at time t2. So see, we have a very similar terminology as we used in kinematics. So theta A is called angular position. Theta A is called angular position. Okay, angular position किसी reference से measure करना है, so our reference is OO dash. OO dash is our reference. OO dash is our reference. Yes, starting point. So theta is angular position at t is equal to t1. Similarly, theta B is angular position at t is equal to t2. Okay, what is A and B? A and B is the position. A and B is the position. But अगर position measure करना चाहे तो बहुत ही complicated way में represent करना होगा उसको. X cos theta, Y cos theta, बहुत सारे terms आ जाएंगे. So we write theta A. Theta is angular position of A, and theta B is angular position of B. Now, after the defining this, we can define the angular displacement. After defining angular position, I can define angular displacement. So the basic definition of angular displacement, that is change in angular position. Change in angular position. So angular displacement can be written as theta, delta theta. You can write this as theta final minus theta initial. Theta final minus theta initial. इस केस में क्या हो जाएगा? Theta B minus theta A. Theta B minus theta A. That is the angular position. में change कितना आया? That is angular displacement. So we can define angular displacement as change in angular position. So final minus initial, or theta B minus theta A. Okay. After defining angular displacement, you can define average angular velocity. Angular velocity, पहले average velocity figure out करते थे, अभी average angular velocity. So average is displacement. Average velocity is displacement upon time taken. Delta theta upon delta t. That would be theta B minus theta A upon t2 minus t1. और similar करने के लिए let me write this as theta 1 and theta 2. At A this is 1, at B this is 2. So I can write this as theta 2 minus theta 1. Theta 2 minus theta 1, theta 2 minus theta 1 upon t2 minus t1. That is average angular velocity. Alright, so there is no issue with this. Angular velocity में change कितना है? That is this much.
और
Yeah.
इसके यूनिट क्या होगी?
See, angle measure करते हैं हम radians में. So angular displacement का unit हो जाएगा radians. और ये यूनिट हो जाएगा रेडियंस पर सेकेंड। Draw this and note it. Now average angular velocity define करने के बाद we can define instantaneous angular velocity. Instantaneous angular velocity. So instantaneous angular velocity means angular velocity at any instant. For that, we take the concept of limit. So d theta by delta t, delta theta by delta t. अगर time बहुत ही small हो जाए, in that case, you can write omega as d theta by dt. D theta by dt. That is rate of change of angular position with respect to time. So ये जो formulas हैं, they are similar to the formulas in kinematics. Note this हो जाए तो tell me. So here we defined angular displacement. पहला angular position था. Angular position is with respect to a reference. And if you have angular position, you can define angular displacement. And average angular velocity is delta theta by delta t. And instantaneous angular velocity is d theta by dt. D theta by dt. Now see, if suppose the object is rotating or different angular positions with omega is different. Let us say at some time t1, the angular velocity was omega 1. And at some time t2, the instantaneous angular velocity was omega 2. Okay. So omega 1 is angular velocity at time t1. Angular velocity at time t1. Similarly, omega 2, that is angular velocity at time t2. So दोनों टाइम पे angular velocity पता है, of course you know the radius. So we can define average angular acceleration. Average angular acceleration, that will be change in angular velocity upon change in time. So average angular acceleration is denoted by alpha. You can put a bracket for average. That is delta omega by delta t. Or you can write it as final omega minus initial omega divided by t2 minus t1. The average angular acceleration. And if you have average angular acceleration, so time को बहुत छोटा कर दिया, then you'll get instantaneous angular acceleration. So instantaneous angular acceleration, that is denoted by just alpha. Alpha will be the rate of change of angular velocity, d omega by dt. All these formulas are important. This is for average, for instantaneous angular acceleration, and this previous one This is for angular displacement. Then this one for average angular velocity. And then this one for instantaneous angular velocity. Yes, sir. तो दो बेसिक रिलेशंस आ गए मींस आफ्टर डिफाइनिंग एंगुलर पोजीशन हमेशा के लिए एंगुलर पोजीशन डिफाइन करने के लिए यू हैव टू नो द रेफरेंस. आफ्टर दैट यू कैन डिफाइन ऑल दिस क्वांटिटीज. तो जो दो बेसिक रिलेशंस आ रहे हैं फ्रॉम इन द फॉर्म ऑफ differential equation, that is first is omega is d theta by dt, that is angular velocity's rate of change of angular position. Second relation is alpha is equal to d omega by dt. Okay, अच्छा एक और रिलेशन डिराइव कर सकते हैं. So I know that alpha is d omega by dt. तो एक d theta से मल्टीप्लाई डिवाइड कर दिया जाए तो d theta by dt हो जाएगा ओमेगा. So this becomes omega d omega by d theta. एक थर्ड रिलेशंस जो आ जाते हैं that is alpha is equal to omega d omega by d theta. So three equations of motion हमने पढ़ा हुआ था in differential equation. For in the same way we have three equations for circular motion in differentiable form. These are always valid for circular motion. Always holds for circular motion. Always holds for circular motion. But see, if alpha is constant, then हमने तीन equations निकाले थे. V is equal to u plus at जैसे वहां पे था. Now these are very similar to those equations. V is equal to dx by dt, A is equal to dv by dt, and A is equal to v dv by dx. Just to scale analogous है. And if वहां पे A constant होता है तो तीन equation of motion आते हैं. यहाँ पे भी if alpha is a constant, you can integrate these equations to get three equations. First one will be इसको integrate करेंगे. So alpha is equal to d omega if alpha is a constant. Let's separate this from this previous thing. If alpha is a constant, so alpha is equal to d omega by dt. Let us say हमारा motion rest से start हो रहा है और if alpha is a constant and at t is equal to 0, जब time 0 है तो theta की value theta naught है and omega की value omega naught. That is your initial angular velocity and initial angular position. So alpha is equal to d omega by dt. इसको ऐसे लिख सकते हैं d omega is equal to alpha dt. इसको इंटीग्रेट कर सकते हैं. जब टाइम 0 था तो ओमेगा की वैल्यू ओमेगा नॉट थी. जब टाइम t था तो लेट अस से ओमेगा वाज ओमेगा. तो d ओमेगा का इंटीग्रेशन हो जाएगा जस्ट एन ओमेगा. एंड अल्फा इज अ कांस्टेंट. सो अल्फा कांस्टेंट जो है इंटीग्रेशन के बाहर आ जाएगा एंड विल गेट dt का इंटीग्रेशन इज t. तो अपर लिमिट लोअर लिमिट पुट करेंगे यहाँ पे ओमेगा माइनस ओमेगा नॉट इक्वल्स टू अल्फा टी. यहाँ से फर्स्ट इक्वेशन आ जाएगा ओमेगा इज इक्वल टू ओमेगा नॉट प्लस अल्फा टी. दैट इज द फर्स्ट इक्वेशन. आई डोंट थिंक अब सेकंड इक्वेशन फाइंड आउट करने में बहुत दिक्कत आएगी. ओमेगा ऑलरेडी आ चुका है. so omega is equal to d theta by dt लिख देंगे. Next is we want theta as a function of omega. So we can write d theta equals to omega dt. Omega already पता है हमें टाइम के टर्म में, टाइम के फंक्शन. So d theta would be omega naught plus alpha t dt. Can integrate this. So जब टाइम 0 था तो थीटा was theta naught. और जब टाइम t था So let us say theta की value is some general value theta. You can integrate this. So d theta, theta naught theta, 0 to t. d theta का integration आ जाएगा theta. And omega naught constant है तो integration आ जाएगा omega naught t. और t का integration हो जाएगा t square by 2. So half alpha t square by lower limit is 0, upper limit is t. यहाँ से रिलेशन आ जाएगा थीटा माइनस थीटा नॉट उधर ले जाएगी तो थीटा इक्वल्स टू थीटा नॉट प्लस ओमेगा नॉट टी प्लस हाफ अल्फा टी स्क्वायर. ये हमारा सेकंड इक्वेशन ऑफ मोशन है इन सर्कुलर मोशन. When alpha is a constant, so it's like x is equal to x naught plus ut plus half at square. बिल्कुल वैसा ही रिलेशन. x is equal to x naught plus ut plus half at square. But instead of linear motion यहाँ पे circular motion है. Correlation already आ गया. Similarly, you can get third relation from here. Alpha is equal to omega d omega by d theta. Okay, so ये दो relations derive कर लिए. तो see ज़्यादा difference नहीं है इसमें और linear motion में equation wise ज़्यादा difference नहीं है. कभी visualize करना that is of course a whole new thing. तो equations आगे third equation भी कर लेते हैं. I think students ने कर भी लिया होगा. Anybody got the third relation? You can tell me. यहाँ से आगे alpha. हाँ, tell me the relation.
सर मतलब इक्वेशन बोलूं.
हाँ, final equation.
2 अल्फा इंटू थीटा माइनस थीटा नॉट
Correct.
इक्वल्स ओमेगा स्क्वायर माइनस ओमेगा नॉट स्क्वायर.
Correct. So omega square is equal to omega naught square plus 2 alpha theta minus theta naught. ये उस relation की तरह है. V square is equal to U square plus 2A into delta X. Like that. Let's see the similarity. Mathematics wise बहुत ज़्यादा difference नहीं है. It's exactly the same, बस notation या term change हुआ है. कैसे find out करना है? इसको omega d omega alpha d theta. Alpha is a constant, तो इसको direct integration कर सकते हैं. When theta was theta naught, omega was omega naught. When theta is 0, omega is omega. So यहाँ से this would be omega square by 2. Omega का integration would be omega square by 2. Lower limit, upper limit, और so alpha into theta minus theta. Alpha d theta का integration हो जाएगा theta. Lower limit, upper limit. अच्छा किसी को डाउट आ रहा है इसमें तो पूछ सकता है. ऐसा नहीं कि मैंने ऑलरेडी एक बार पहले पढ़ाया हुआ है तो फिर से नहीं पूछ सकते. You can ask me again. It will be like this. और इसको मॉडिफाई करके फाइनल इक्वेशन लिख सकते हैं. So final three equations we can write it like this, and these are only valid when alpha is a constant. Alpha is angular acceleration. अभी हम समझेंगे अच्छे से angular acceleration का मतलब क्या होता है. But mathematically we have understood that is rate of change of angular velocity is angular acceleration. If alpha is a constant, then omega is equal to omega naught plus alpha t. पहला relation आ गया. Second relation is theta naught plus omega naught t plus sin. Theta naught plus omega naught t plus half alpha t square. और थर्ड रिलेशन आ जाएगा प्लस साइन होना चाहिए. ओमेगा स्क्वायर इज इक्वल टू ओमेगा नॉट स्क्वायर प्लस 2 अल्फा थीटा माइनस थीटा नॉट. लाइक दैट. These are the three equations. याद रखना है. एंड ऑफ कोर्स अगर काइनेमेटिक्स वाले इक्वेशंस याद है तो ये भी याद रहे. तो इसके बेसिस से पहले कुछ क्वेश्चंस करते हैं फिर आगे बढ़ते हैं. किसी को डाउट है यहाँ तक? अल्फा का यूनिट होता है रेडियन पर सेकंड स्क्वायर. let us say alpha is 0.5 radian per second square, and at t is equal to 0, omega naught is 0, and theta naught is 0. Then find angular velocity, and angular position at t is equal to 4 seconds. सिंपल सा क्वेश्चन है. अल्फा की वैल्यू दी हुई है, मींस अल्फा इज अ कांस्टेंट. फाइंड angular velocity and angular position at t is equal to 4 seconds. Easy सा क्वेश्चन है, फटाफट कैलकुलेशन करना है, तुरंत फाइंड करना है. अगर फर्स्ट वाला हो जाए तो टेल मी द आंसर ना. नमन सेकंड वाला हो जाए, देन यू हैव टू टेल मी द आंसर. पिशागर फर्स्ट वाला आंसर आ जाएगा.
सर कर रहा हूँ, भी नहीं हो.
अच्छा, टेल मी व्हाट अप्रोच यू आर फॉलोइंग, कौन सा फॉर्मूला अप्लाई कर रहे हैं इसमें.
सर डेल्टा थीटा अपॉन डेल्टा टी.
डेल्टा थीटा अपॉन डेल्टा टी नहीं, यहाँ पे तो सी अल्फा कांस्टेंट दिया हुआ है ना. अल्फा की वैल्यू एक नंबर है, दैट मींस इट्स अ कांस्टेंट. फिर अल्फा कांस्टेंट हो, ये तीन इक्वेशन ऑफ मोशन यूज कर सकते हैं. वैष्णवी, कैन यू टेल मी द आंसर फॉर दिस.
0.
0. What is your angular velocity is 0?
Yes.
नहीं, सी अल्फा की वैल्यू गिवन है. We have to find angular velocity. What is our angular velocity? Omega. So omega find out करना है, that is omega naught plus alpha t. Omega naught is 0. मुझे t is equal to 4 सेकंड पे चाहिए. Initial angular velocity 0 है. Alpha is given as 0.5 and 4 सेकंड पे चाहिए. So this will be 2 radian per second. Nirmit's answer is right. Yes. Sending the answer in chat, and omega is equal to 2 radian per second is right. वैष्णव, इसी तरह थीटा फाइंड आउट करना है. ये वाला फॉर्मूला अप्लाई करना है थीटा के लिए. Since alpha is a constant, we can use these three relations. Solve it and tell me the answer. बिल्कुल काइनेमेटिक्स का क्वेश्चन है, बस वेलोसिटी, पोजीशन, एक्सेलरेशन की जगह एंगुलर वेलोसिटी, एंगुलर पोजीशन और एंगुलर एक्सेलरेशन. p की जगह ओमेगा लिखते हैं, a की जगह अल्फा लिखते हैं. 4 is correct. So half alpha t square, बाकी सब तो 0 हो जाए. Time is 4 seconds per 4 square, that is just 4 radians. यूनिट लिखना नहीं भूलना, यहाँ पे रेडियंस होगा 4 radians. Question number 2, Naman. Question number 2, can you tell me कितना आंसर आएगा?
4.
4 किसकी वैल्यू 4? एंगुलर वेलोसिटी की वैल्यू 4 आ रही है या
एंगुलर वेलोसिटी?
एंगुलर वेलोसिटी. 4 is correct. So omega is omega naught plus alpha t. Omega naught 1 था, alpha is 1.5 into 2, that will be 4. यूनिट क्या लिखेंगे इसकी?
रेडियन पर सेकंड.
रेडियन पर सेकंड. वेरी गुड. ये हो जाएगा रेडियन पर सेकंड. और एंगुलर पोजीशन कितना आ जाएगा?
पोजीशन अभी नहीं निकाला।
ओके, कैलकुलेट करके बताना है फिर।
सर आप एक बार फॉर्मूला दिखा सकते हो क्या ऊपर?
ये फॉर्मूलास
हाँ सर।
बेशक इससे पहले जो भी कराया उसके नोट्स बनाने हैं, राइट? You're making
हाँ
proper
सर।
notes, ना?
हाँ सर वही बना रहा हूँ।
Okay.
Sir, can you show question 3?
नमन, क्वेश्चन 2 का सेकंड पार्ट आया क्या?
हाँ सर बस।
ठीक है, ठीक। Tell me first time. क्वेश्चन नंबर 3 में अल्फा गिवन है और ओमेगा चेंज हो रहा है। I have to find delta theta. So I'll use this formula: omega square is equal to omega naught square plus 2 alpha theta minus theta naught. Theta minus theta naught ही हमारा angular displacement. Delta theta minus theta naught is our angular displacement. So delta theta you have to find. That will be omega square minus omega naught square divided by 2 alpha. अदिति, क्लियर हुआ ये वाला क्वेश्चन? तो नमन, क्वेश्चन 2 का आंसर कितना आ रहा है? This will come as 15 radians, and this with is getting 3 radians. So 4 square minus 2 square, that is 12. 12 by 2, that is 6 by 2, that is 3. 3 radians is correct. 3 radians. So 3 radians pi से थोड़ा सा कम है ना? pi radian कितना होता है? Pi radian is 3.14 radian. Pi radian is 180 degree. So 180 degree से थोड़ा सा कम होगा, approximately half rotation. Just to give you an idea, 3 radian is half rotation. 6.28 radians is full rotation. That is our definition of pi. Pi का मतलब होता है circumference divided by diameter. ठीक है, यहाँ तो कोई और क्वेश्चन, कोई डाउट?
No, sir. समझाओ.
Okay. After this, so give an assignment sheet of this. यहाँ पे these questions are very similar to the kinematics वाला part. अच्छा, let us say अगर alpha constant नहीं होता है, then what happens? So a particle undergoes a circular motion. A particle undergoes circular motion. Such that theta varies as time. Theta varies with time. Theta is angular position. Theta is angular position. Theta varies with time given by this relation. Theta is equal to 6t. का cube, or let me give t cube by 6. Okay, t is in seconds and theta is in radians. Theta is in radians. So your question is find omega as a function of time. Second, find alpha as a function of time. Then third, find alpha as a function of theta. Theta given as a function of time. To find these three quantities, and of course theta time के साथ vary कर रहा है, then it is highly likely कि हमारा alpha constant नहीं है. अगर alpha constant नहीं है, then you will be using these three relations. Alpha is equal to d theta d omega by dt. No, पहला वाला is omega is equal to d theta by dt. Or alpha is equal to d omega by dt. And third is alpha is equal to omega d omega by d theta. ये तीनों relation use करना है because it's highly likely that alpha is not a constant. All this, figure it out. Aditi, can you tell me the answer?
Sir, I'm still doing it.
Okay. First वाला हो गया?
No, sir.
See, first one omega is d theta by dt. So you can differentiate this as a function of time with respect to time. So t cube by 6 का differentiation क्या हो जाएगा time के respect में? dt of t cube by 6. 1 by 6 बाहर आ जाएगा. Constant बाहर आ जाता है अगर multiplied होता है तो. What is differentiation of t cube?
Sir, it's 3t square.
3t square. So cube और 6, 3 और 6 cancel out होके 2 हो जाएगा. So omega is t square by 2.
Huh.
Similarly, tell me the value of alpha. Alpha को लिख सकते हैं d omega by dt. And you have already got omega as a function of time. Omega is t square by 2.
Sir, वो t आएगा.
हाँ, सिर्फ t आएगा. Alpha is equal to t. अच्छा, यहाँ पे units अलग अलग होंगे because some constant का unit multiplied है. So alpha is a function of theta find out करना है. Then what you can do? You already know alpha is a function of time and time as a function of theta. So time as a function of theta लिख सकते हैं. इसको 6 theta उधर ले गए, so this 6 theta to the power 1 by 3. So time is 6 theta to the power 1 by 3. So alpha is t, that is equal to 6 theta to the power 1 by 3. So that gives you alpha is 6 theta to the power 1 by 3. That is alpha as a function of theta.